Hello again, welcome to Pandabood tutorials. In today's video, in Electrical Circuits 3, we will be talking about fuses and what happens when you add more light bulbs, the resistance. Let's start. The fuse is a device used for safety. As you can see, it's just made of a very thin wire inside. The job of the fuse is to cut, snap, when there is more current than the fuse can take. So for example, I'm gonna stop this circuit, I'm gonna delete the current, the ammeter. I'm gonna put this fuse right here. Now this fuse rating is up to 4 amps. What does that mean? That means this cannot take more than 4 amps. So if your light bulb cannot take more than 4 amps, let's say, you will buy this fuse and connect it to the circuit. If by any chance someone add more voltage to the circuit, which will make more current, the fuse will be doing the protection for your light bulb. Let's see, it's all fine. So I need the ammeter again to show you the actual measurement. So let's connect the ammeter one more time. Now you can see it's 2.7. Keep your eye on the ammeter to read the amps and see what happens when it's at 4. 3.2. Almost there. Snap. Now you need to change this fuse, which is cheaper than the light bulb or the batteries or other components in your circuit. So fuses are used in safety. This fuse will be cut, and when it cut, it will make an opening in the circuit, and that's why electricity will not be flowing, protecting your circuit from the damage. So let's change it. Let's bring another one. This time let's change the current rating to be 14.5. So what does that mean? It will still be working even if it's more than 4, but once I reach very close, done, 14.5 is reached and this one is burned. So let's fix it from here. Again, fix it again. What do I need to do before I'm fixing it? Decrease the voltage so the current will be less than 14.5. Now it's exactly 13.59 amps, so it's fine. And now let's explore what happens if you add more light bulbs for one battery. So I'm gonna delete this circuit. I don't need this circuit anymore, and I'm gonna keep this simple circuit for comparison. Now let's bring this back to 9 volts as it was to compare them properly. So I'm gonna have the same as before, but one battery, and this time I'm gonna add 1, 2, 3 light bulbs. But just to show you in a better way, I'm gonna add one light bulb at a time, and I want you to compare what is happening to the circuit when I have more light bulb and one battery. So let's connect this, and I need a switch, of course, and now I need a wire between these two light bulbs and then coming back again to the switch here. 3, 2, 1. Oh, what is this? As you can see, the brightness is less. These two light bulbs are dimmer than this one. Now, can you guess what happens when I add the third one? Let's cut this wire, bring this one here, and put some space for this light bulb, and then let's connect them. 3, 2, 1. Again, it's dimmer. And just to compare in a better way, of course you can notice this current is less than this because it's going slower than here. So can you guess what the current will be in this circuit? So let's bring the ammeter and connect it here to see how much current we have. So if this is 0.9, my guess will be, if I have 3 light bulbs, that my current will be 0.3. And that's correct, because you have 3 light bulbs. That's why your current will be 3 times less. And the reason for that is, each one of the light bulb is using energy. It's using this energy produced by the battery, and when you have 3 of them in series, these 3 light bulbs share this electricity together. That's why you divide it by 3 and you get the current to be 0.3 in this circuit. Now, why this is happening? Because each of these light bulbs has a resistance. Now, this is a new thing you have to know. After you know, now you know about voltage and current. Now it's your time to know about resistance. What is resistance? Resistance is measured in ohms. As you can see here, it's resisting the electricity. It's using the electricity in the light bulb, and you can think about it as it's resisting the electricity, doesn't let the current to flow. So now it's the opposite relationship. Previously we discovered that if you have more voltage, you have more current, the electricity and the electrons are going faster. But here, if you have more resistance, you will have less current and the electricity will be less, electrons will be flowing slower. So if I add another light bulb, what does this do to the circuit? That's increasing the resistance of the circuit, and you will see that the current will be even less. Now, just like how we explored before, how can we get the same effect with only one light bulb? All what you need to do is to click on the light bulb and now increase the resistance. Increasing the resistance will make the current less, and with only one light bulb I can even have less current than 4 of them. Why? Because I increased the resistance. But it's still brighter, because you can think about this brightness is the same as is actually less than these 4 together, but this current is giving the brightness for 4 of them. That's why this current is showing more brightness, because you're only using one light bulb. But if I keep adding more resistance, more resistance, more resistance, you will see the current is very low here compared to this one. Let's bring this back again to normal. It was 10 ohms. This is the measurement of the resistance for this light bulb. Now, if I have more than one light bulb in the circuit and I increase the resistance for one of them, what do you think will happen? Some of you might say and might guess that if you add a resistance only for this one and keeping the others 10, they will think, hey, you will have less electrons here but more in these ones. That's actually not true. You will have the same electricity going in all of them, but since this one have more resistance, so that means it's using more electricity than the others, so the brightness of this one will be more than these 3. Let's see. Adding more resistance for this one decrease the current in all of them, but because this one have more resistance, it uses more energy than its neighbors. That's why it has the most brightness. So if they have the same resistance, all of them will be at the same brightness, but if they have different resistance, the one with more resistance will be brighter than the others. So that's it for today. In Electrical Circuits Part 4 video, we will be talking about a device called the resistor. So if you want to learn about it, stay tuned. Until next time, Pandabood.